Hello everybody, welcome to another video. This time I'm going to be solving a boundary value problem of a given differential equation. And I'm going to use the superposition approach and undetermined coefficients to find the general solution. That's the main point of the video, is to solve for the general equation of a given differential equation using the undetermined coefficients, and then solve for the boundary value problem. So the given differential equation is y double prime plus y equals x squared plus 1, and the boundary conditions are y of 0 equals 3 and y of 1 equals 0. So the first step, like always, is going to be to solve for the complementary function, which is the auxiliary equation, equal to 0. So, solving for m, we have m equals I, which makes alpha equal to 0, beta equal to 1, and the complementary function is c1 cosine of x and c2 sine of x. It's pretty late right now, it's 11:30, and I've been working on these problems for the past couple of hours, and I'm pretty tired right now, so hopefully I don't make any silly mistakes, but no excuses. We'll just make it through. So now step 2 is going to be to find the particular solutions form. So we look at g of x right here, and it's going to be a quadratic equation. So it's ax squared plus bx plus c. None of these terms here repeat with these terms here, so we don't have to multiply anything by x. So y of p prime equals 2ax plus bx, and then we differentiate it again. So y double prime of p, whoops, that's not x, that's just b. And then y double prime is 2a. So now we plug this back into the equation. 2a plus y plus ax squared plus bx plus c is equal to x squared minus 1 plus 1. So now we just set like terms equal to like terms. We have a is equal to 1, so that's easy. Then we have b is equal to 0. And then we have 2a plus c equals 1. We already know a equals 1, so c is negative 1. Because 2 times 1, and then subtract 2 from 1, so c is negative 1, which makes the particular solution equal to x squared minus 1. And then part 3, the general solution, is the complementary function plus the particular solution is c1 cosine of x plus c2 sine of x plus x squared minus 1. And now part D, the boundary conditions. Y of 0 equals 3. We'll say 3 equals c1, and then minus 1. So c1 equals 4, which means y equals 4 cosine of x plus c2 sine of x plus x squared minus 1. The second boundary condition is y of 1 equals 0. So 0 equals cosine of 1 is, isn't that, well, 0, there's not really it's kind of weird because I'll just write 4 cosine of 1 plus C2 sine of 1 plus 1 minus 1, which is 0. Sine of 1, that's like a really weird number. Sine of 1 and cosine of 1, there's not a clean value of those. So I'm just going to solve for C2 in terms of sine of 1 and cosine of 1. C2 equals negative 4 cosine divided by sine is negative 4 cotangent of 1, which makes y equal to 4x, or 4 cosine of x minus 4 cotangent of 1 times sine of x plus x squared minus 1. Now I'm going to enter this into WebAssign, see if the answer is correct. So give me a second here. 4 cosine of x minus 4 cotangent 1 sine of x plus x squared minus 1. The answer is correct. So if you watched the whole video, thank you for watching. Appreciate you, and have a good night.